All right, we're now going to be talking about the stochastic process. Grade 12s? Gentlemen? It just goes through a summary here. Are any series of events where the outcome isn't known and is simply based on probability? Ben? The opposite of a stochastic process is a deterministic process where you know the outcome. For example, say you get a quiz and leave it blank. Handing it in is a deterministic process. You know that the outcome will be a mark of 0. If you guess on all the questions, do you have an extra one? Oh. What? Pardon? Oh, it's up at the front. I'll pass it around. Okay. So it says if you guess on all the questions, your mark is the result of a stochastic process. There are several possible outcomes. There are several possible outcomes, and there's all a likelihood of it happening. Pretty much everything we have done in probability could be considered a stochastic process where the outcomes have been equally likely. To solve today's problem, we're going to use a tree diagram just like we did earlier in the course. The only difference is this time is that we won't consider all outcomes to be equally likely. We'll assign specific probabilities to each step, which may or may not be dependent on previous outcomes. Okay, so here's the example that we did before. What is the probability of getting 2 heads if you flip a coin 3 times? So the way we did this before, again, I'm going to do this, drawing a tree diagram. So on my first roll, my first flip, I can get a heads or a tails. There's a 50% probability that I will get a head or a tails. On my second flip, I can get a head or a tails, a head or a tails. And again, I have a 50% chance of getting these results. Then I can go to my third flip of a coin, head, tails, head, tails, head or tails, head or tails. And again, each one of these is represented by 50%. There's a 50% chance of flipping each one of these. So I'm just going to write out all the outcomes here if I follow the tree diagram. This first one here represents flipping at 3 heads. My next one is a head, and a tails. Over here, I have a head, a tails, and a head, tails, tails. Then I can have tails, head, head, tails, head, tails. Then I can have tails, tails, head, tails, tails, tails. This is what we did the first time. Does anyone have any questions about what I've just drawn up there? Okay, the probability of getting 2 heads. So again, how many outcomes did I have here? There are a total of 8 outcomes. And out of these 8 outcomes, I have 3 of getting 2 heads. Here's 1, here's 2, and here's 3. Those are the 3 possible ways I can get 2 heads. So the old way to answer this question was saying the total number of possibilities is 8, your NS. Your NA is equal to 3. There are 3 ways to flip exactly 2 heads. So the probability of this happening is 3/8. That's old news. Okay, the new way, the stochastic process answer, which, this is a pretty straightforward question that you can do it this way, which is fine. But there are going to be some questions where you can't do it this, or you can't, it won't always be this easy. So what I'm going to do is I'm going to follow the branches that gives it to me, the heads, heads, tails. So I have the heads, then I have the heads, and then I have the tails. So it kind of looks like this. I do a head, a tail. In order for me to figure out that probability, what I can do here, the new way would be saying, okay, on my first branch, the new way, the probability of this happening is equal to, well, in my first branch here, the probability is 0.5 times 0.5 times 0.5. That was my first case. 0.5 times 0.5 times 0.5. Sure. My next case, I can have, I can do my heads, my tails, and my heads. So that's an or. So I can have that, the first case, or I can have my next case here, which is 0.5 times 0.5 times 0.5. My third case of this, I can flip the tails, heads, or heads. So that would be saying, so I'm going to add that with 0.5 times 0.5 times 0.5. Now, if you multiply all of this all together, you will get 0.375, which is 3/8. Two different ways to get the exact same answer. We're going to do some examples where the new way is the only way to do it. Okay? Okay. The next piece here, problem 2. Oscar is a nervous test writer. He figures that if he gets a question right on a test, he has an 80% chance of getting the next question right as well. But if he gets it wrong, there's only a 40% chance of getting the next question right. He's writing a test that has 3 questions on it. Natalie, Pat, if he has a 70% chance of getting the first question correct, what is the probability that he'll get perfect or a pass, which we'll consider at least 2 out of 3? Okay, so they give us lots of information here. I'm going to start with this last piece. It says if he has a 70% chance of getting it right on the first question. So the first question, I'm going to draw a tree diagram to help us out here. He answers the question right. He answers the question wrong. The probability that he gets the first question correct is 70%, so that becomes 0.7. The probability that he gets it wrong becomes what? 0.3. Are we all okay with this first branch? Okay. Now, for the second question, he can get it right or wrong. right or wrong? Now, he got the first question correct, so it says that he figures if he gets a question right on the test, he has an 80% chance of getting the next question right. So this, I'm following the first one. If he answers the first one correct, there is an 80% chance that he will get the next one correct, which means what percent will he get? What's the chance that he'll get it wrong? 0.2. Okay, now I have to then look at this next case here. If he gets the first question wrong, what is the probability that he gets the second question correct? If he gets it wrong, there's only a 40% chance of getting the next question correct. So here comes 40. So what's the probability that he answers the first question wrong and then the second question wrong? What is it? 0.6. Are we okay with this right now? Okay, now I have to go to my third round. Okay, if he answers the first question right, the second question right, what's the probability that he gets the next question correct? What do you think? How about we go up and down the road? Joanna, help me out. He answered the first question correct, second question correct. What's the probability that he gets the third one correct? Not 0.9. How'd you get 0.9? So if he gets a question correct, if he figures if he gets a question right on the test, he has an 80% chance of getting the next question right as well. So if he got it correct, the second question correct, the third question, there's an 80% chance that he'll also get that correct. Are you okay with that, Joanna? Okay, which means what percent will he get wrong? Good, so 0.2. Then, if he gets the first question correct, second question wrong, what is the probability that he gets the third question correct? Very good. Because he answered the second question wrong, which means how much, or what's the probability that he gets it wrong again? What's the probability for this W? 0.6. Okay, Johnny, he answered the first question wrong. He then gets the second question correct. What's the probability that he gets the third question correct? 0.8, very good. Which leaves what percentage to get wrong? Good. David, my last branch on here, if he gets it wrong, what's the probability that he gets it right for the third one? Very good. And the probability that he'll get it right? Or sorry, you're right. Probability that he gets it right is 0.4. The probability that he gets it wrong is 0.6. Okay, so if I go through my process here, where I just write out my results, I have on my first diagram here, I can get it right. My next one, I can get right, wrong. Then right, wrong, right. Right, wrong, wrong. Right, wrong, wrong, or wrong, right. Then I can have wrong, right, wrong, right, and then 3 wrongs. Okay, so if I look here, I want the probability that he gets it perfect, which is this case here, right, 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 right here. If I look at the percentages for those, what would I multiply together, Dylan? Good, 0.7 times 0.8 times 0.8. That's the probability that he gets it perfect. So I'm going to write here the probability that they get perfect I can spell is 0.7 times 0.8 times 0.8, which gives me a probability of what, Noah? Okay, hit equals again. Does it give it to you as a decimal? Yep. Okay, that's a probability that he will get perfect. Then I have to look here. Okay, what is the probability of a pass, which is at least 2 out of 3? So at least 2 out of 3 also includes your perfect, because 3 out of 3 means that he also passes. So that means that I'm also looking at this case, and this case. So there's 2 other cases that I have to have here. So for this next one, Mitchell, what would I write for the probability of right, wrong, right? Or right, right, wrong, sorry. Very good. And what about Spencer, right, wrong, right? What would I write for that? Very good. And my final case, Scott? Not 0.4, or is it? Yes. 0.4 times 0.8. Very good. Okay, so the probability of a pass is including, so I'm just going to write the cases here. So I have right, 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 plus right, right, wrong, plus right, wrong, right, and then plus wrong, right, right. So when I do that, if I were to multiply all 4 of these cases together, you should get 0.448 plus 0.112 plus 0.056 plus 0.096. And when I add them all up, I get 0.712. So there's a 71% chance that you pass. Any questions with that, setting up the tree diagram? Okay, going to the next problem. Lisa and Brad play rock, paper, scissors. Lisa knows Brad's pattern well, so she wins 70% of the time. If they play 3 times, what is the probability that she wins at least 2 of the rounds? Okay, so I'm going to start off here. I'm going to write the winner. L for Lisa, B for Brad. Okay, Lisa knows, so there's a 7, so she wins 70% of the time. So what would I write for my first tree branch here? Pardon? Hang on. Curtis, what would I write here for, what's the probability that Lisa wins? 0.7. And the probability that Brad wins? 0.3. Okay, so if Lisa wins the first one, what's the probability that Lisa wins the next one? David, can you give me this branch here? Very good. And if Brad wins the first one, Billy, can you please help me out with this next branch? 0.7 and 0.3. Again, I can go Lisa, Brad here. Eric, can you do the next tree branch for me here? The top one. For Lisa and for Brad. 0.3. And my next tree branch down here, Pat? 0.7, 0.3. Natalie, my next one? And my final one here, Mike? 0.7, 0.3. Very good. Okay, so it says here, if they play 3 times, what is the probability that she will win at least 2 of the rounds? So, Michaela, can you tell me what are my cases that I'm going to look at here out of all of them on this tree diagram? Good. Lisa, Lisa, Lisa. Okay, sorry, just give me one moment. Ben, tell me what another case is that she wins at least 2 of the rounds. Good. Give me another case, Joanna. Good. And then give me my final case here, Johnny. Brad, Lisa, Lisa. Okay, so those are all the cases where she wins at least 2 of the rounds. David, can you tell me what is the probability of Lisa, Lisa, Lisa winning? Which gives me an answer of what? Good. 0.343. Dylan, what do I do for Lisa, Lisa, Brad here? Which gives me a probability of? Very good. And Noah, do the next one for me. Very good, which gives me the probability of what? Very good. And my final case here, Mitchell? Which gives me? Very good. So the probability that she wins at least 3 times, so the probability of this event happening is 0.343 plus 0.147 plus 0.147 plus 0.147, which gives a probability that Lisa will win at least 2 out of 3 rounds, 0.784. Okay, problem 4. It says here, there is a 40% chance that it will rain on Friday. If it rains on any given day, it is 10% less likely to rain on the next day. What is the probability that it will rain at least once on the weekend? Okay, so this one's a little bit tricky because it kind of carries through. So I have here is Friday. The probability that it will rain on Friday versus not would be what? Well, how would I set this up? Spencer, can you help me out? There's a 40% chance that it will rain, which means what percent chance that it won't rain? 0.6. So it says here, if it rains on any given day, it is 10% less likely to rain on the next day. If it doesn't rain, it's 20% more likely to rain the next day. Okay, so what do I have to do for this next one here? If it rains on Friday, what is the probability that it will rain on Saturday? What do you think, Scott? 0.3, which leaves the percentage to not rain is what? 0.7. Are we okay with that? If it doesn't rain on Friday, what is the probability that it will rain on Saturday? Curtis, what do you think? Not 0.4. Mike? Not 0.8. It's actually 0.6. Okay, how do we get 0.6? The probability that it was to rain on the first day was 40%. Because it didn't rain, there's a 20% more chance that it's going to rain. So I take this 0.4, I add it with the 20% more, which gives me the 0.6. Which means the probability that it doesn't rain is what? Scott, can you help me, or Curtis, can you help me out? 0.4. Okay, Sunday. What is the probability that it will rain on Sunday if it rained on Saturday and on Friday? David, can you help me out? Not 0.5. So if it rains, it's 10% less likely to rain the next day. 0.2. Which means the probability that it won't rain is 0.8. Okay, if I look at my next tree branch, rain, not rain. So if it didn't rain on Saturday, what is the probability, Billy, that it will rain on Sunday? Good. How'd you get 0.5? Very good. 0.3, because there was a 30% chance on Saturday. So I bump it up 20% because it didn't rain. So it's 0.5, which means 0.5% that it won't rain. Okay, if it doesn't rain on Friday, rains on Saturday, what is the probability that it will rain on Sunday? Eric? Good. 50 and 50. So there was a 60% chance on the Saturday. So because it rained, it's 10% less likely. So 60 minus 10 gives you the 50%. My last case here. What would it be, Pat, if it didn't rain, and then all of a sudden it rains? Pardon? 0.8, 0.2. There's an 80% chance. So it didn't rain, so there's a 60% chance on the Saturday. So if it rains, I bump it up 20%. So 60 plus 20 gives me 0.8. And then which leaves me with 0.2. Eric? Yes. Okay, so Eric just said, what is the probability? He said that instead of adding them all up, why don't you just do the indirect method, which is exactly what we're going to do here. And we can do it both cases. They will give you the correct answer. So what is the probability that it will rain at least once? So again, here, if I look at my cases, I have rain, 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 and it doesn't rain. Rain, no rain, rain. No rain, rain, no rain. Oh, did I miss one? 1, 2, 3, 4. Rain. Oh, you want to know what? I have to do this. On the weekend, so this is part that, again, I'll clarify. On the weekend, we consider Friday to be part of the weekday. So on the weekend, our weekend is Saturday, Sunday for most of us. So I'm just looking at Saturday, Sunday. So I have here rain, 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 no rain, no rain, rain, no rain, no rain, 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 no rain, no rain, rain, and no rain, no rain. So there's a lot of probabilities here. So what I can do here, if the probability that it will rain at least once, so what I can do is I can use the indirect method, which would be saying, what cases would I subtract from this? Eric, what did you say again? Yeah. So here's the no rain. Here's the no rain. So I have those two chances there. So if I look here and I calculate that, there's no rain on that. For me to get no rain, that's saying 0.4 times 0.7 times 0.5. No rain here is 0.6 times 0.4 times 0.2. I'm doing the indirect method. Right, but because their answer depends on Friday, we include Friday's number. So when I find the probability of this, I do 1 minus rain, no rain, no rain, minus no rain, no rain, no rain, which gives me 1 minus 0.4 times 0.7 times 0.5 minus 0.6 times 0.4 times 0.2, which gives me a probability of 0.812. So the probability that it will rain at least once is an 81.2% probability. Okay, any questions with that one? Now, if you figured out all of these other cases that I didn't circle and add them all up, you will also get 0.812. Okay, my final one, I'm actually not going to do it. I'll probably do it on Monday.